Hi friends, we are going on with working with parallel lines, and one good thing to do before you start lesson 3.2 is to remember what type of angles are formed with parallel lines. We had alternate interior, corresponding, alternate exterior, and same side interior. And we had properties that worked with those. Today we're proving that lines are parallel. As a result of those properties, we can go backwards and show that the lines are parallel if they happen. So how do we do that? Just remember when we worked with it before. If I have a conditional statement, which is an if, then statement. For instance, like the following. If two parallel lines are cut by a transversal, then we'll say same side interior angles are supplementary. That is what we worked with in lesson 3.1. We knew this was a property. Today we're going to flip it around and we're going to use the converse. And the converse shows us that they're going to be parallel. So it'd be more like this. If two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. So basically we're flipping it around. Now I had to make it so it works, and by the way that's an and sign, not a plus sign, to work with it. So basically if you know the theorems from the day before, we have to kind of think of the direction. We start with the angles and then we get the parallel lines. Before we started with the parallel lines and we got the congruent or supplementary angles. So we're going to flip it around. So let's just hit this thing. Let's just go for it and get it done. First one is the converse. Notice the words here. We switched our if and then statement around. So first one, if two lines and transversals form corresponding angles that are congruent, and you can put the congruent symbol in if you want, then the two lines are parallel. Remember we had our shortcut method, and the shortcut method, it just saves us a lot of work writing our reasons down. And here's what I want you to write for the shortcut method. Corresponding angles are congruent implies parallel lines. So we're going to go backwards. Here's what they're trying to say. For instance, if I mark the given information, my hypothesis in this conditional statement, if angle 1 is congruent to angle 2. Okay? So right here. Those are corresponding angles. If those angles are congruent, you can automatically assume that line L and line M are going to be parallel to each other. So if I mark those and I have corresponding angles are congruent, I have parallel lines. So it's just kind of the opposite of what we did yesterday. Then we have the converse of the alternate interior angles theorem. So it's doing the same thing. We flip-flop it around. Look what this one says. If two lines in a transversal form alternate interior angles that are congruent again, then the two lines are parallel. So again, we want to use this shortcut method of explaining things. So we go through and we can say, hey, lines. All right. So it's kind of a simple way of keeping those up. So again, how would I mark my diagram? And this is where you guys have to start getting really good at this. And if you've refused to do it so far, change your ways, okay? We should mark the given information. We should always mark the hypothesis part. Angle 1 and angle 2 are congruent. Here's angle 1, here's angle 2. Well, those are alternate interior angles. They're congruent to each other. And this theorem then tells me I can automatically assume now that they're parallel because I have those pair of alternate interior angles are congruent. We do the same type of idea with same side interior angles. Instead of them being congruent, they're going to be what? Same side supplementary. Right on. Remember the little dance I do in class. Same side sup. Same side supplementary. So if two lines in transversal form same side interior angles that are supplementary, then the two lines are parallel. So again, we want to flip this one around. We have same side interior angles are supplementary. Then we have parallel lines. So not too bad. So let's look what we're talking about here. What we're saying is, hey, the measure of angle 2 plus the measure of angle 4 equal 180 degrees. So those two angles right here add up to 180. All right, so they're not a linear pair, but because of that, we can get linear pairs that do this. So we know then that the two lines are also parallel. So we're going to be looking for those traits. Now, those aren't the only theorems that we have. We have two other theorems that are kind of cool that we work with. And then we're going to work examples together. The first one is Theorem 3.5. Now, this one almost is like the law of syllogisms, or LS, or transitive property, whatever you think, for parallel lines. So here's what it says. If two lines are parallel to the same line, okay, so if two lines are parallel to the same line, then they are parallel to each other. Here's what we're talking about, all right? Let's say that line O is parallel to line N, all right? So they're parallel. But we also know, okay, the same thing here, that line M is parallel to line N. That means these will never intersect. So I go in and mark it because it's parallel to N, the same mark. Well, now look at the marks at your other two lines here. They have the same marks. So therefore they have to be what? Parallel to each other. So basically, if this and this happens, what do we know? Then we get the fact that line O is parallel to line M. So it's just a way of getting a new conclusion. But isn't that kind of using LS? You know, they're both parallel to the same line. All right, they're parallel to each other. And then I like the next one too because it's a very common sense one that helps us work out. It's this next theorem. Now remember, don't memorize numbers, just memorize the theorem. It says, in a plane, if two lines are perpendicular, remember the definition means two lines intersecting to form right angles, are perpendicular to the same line. Then they are parallel to each other. And here's what we're talking about, okay? Here we have our lines, and I'll add arrows on there because it's driving me nuts. I didn't put arrows when I drew these initially, okay? We're given this following. Here is your initial statement. If line J is perpendicular to line M, and we have line K is perpendicular to line M, you then can assume what? They're parallel. All right, so we can say line J is parallel to line K. All right, so again, we have our two hypotheses. And kind of like maybe this is the LS of perpendicular stuff. I'm not quite sure, maybe if you want to say it like that. But here's the why behind this. Remember when they're formed, they form right angles. So I'm going to mark the right angle here and the right angle here. Now, looking at that, you need to realize those are two corresponding angles. Are those two corresponding angles congruent? Yeah, they're congruent because we know all right angles are congruent, right? So since those right angles are congruent, we then can conclude, hey, if corresponding angles are congruent, then we have parallel lines. Well, that means then that these two lines are now parallel to each other. Kind of cool. All right, we're going to get back over. We're going to switch this side, and I want you to really pay attention to this because probably the second set of notes is just as important or more important than this first set because I want to make sure you really understand how to do your homework problems.